for the nice intro. So we will just recap quickly what KYVE is and what it does. And then we'll proceed to our products on how to use it or what benefits KYVE brings to you. So first of all, we are Cosmos-based L1 chain. And at our core, we are a data validation and transfer protocol. And what this means is that we build a framework which basically validates any types of data, and we transfer it to like a destination. And we focus on permanent Web3 storage providers as destinations, like Arweave. In case you haven't heard of them, they are like a permanent Web3 storage solution. So you pay once and can store forever, which is quite nice for our use case, since we right now focus very much on archiving the blocks and events of another chains and permanently archiving them to Arweave. And this has some great benefits, like that the blocks are basically the backbone of every blockchain, and they're very crucial and they should not be lost at any point. So with this, we can ensure that they're validated and stored, and users like validators and data analysts can access them at any time. And what the end goal basically is that we are going to build a decentralized data lake. So not only do we want to store Web3 data, but also Web2 data in the future, or like from any other data source, whoever is interested in that. So if we move on, we can just quickly look at the general structure on how we do it. So on our L1 chain, we have the validation logic. So basically, for every data source, we have a designated storage pool. So for example, for Zeta chain, we have like a known storage pool, and also for the state sync snapshots, we have an own storage pool, and for another blockchains, we have another storage pool. And in each storage pool, there are validators in them. And the special thing with the validators are that they all run their own Zeta chain node in the background. So in each round, one proposer gets selected, and he's able to like upload a bundle proposal to Arweave, and all the other 49 validators, because usually there are 50 nodes in the pool, all the other 49 validators, they then pull down the data, check it against their data they found on their local Zeta node, and then they vote on the outcome. And basically, with this setup, we can ensure that there's no disagreement between the blocks, and especially also the events. Since actually in the Cosmos ecosystem, we discovered some inconsistencies, mostly like ordering issues, but also value issues at some point where, for example, there were some faulty implementations. So with this, we can ensure that only valid data is permanently stored, because else it doesn't make any much sense. And after, of course, we have archived the data, we built some solutions to also retrieve it, because once they are on Arweave, they're in a raw form. And so we have 3 products targeted for different user groups, so you can use them however you need. So basically, with the first tool we can start, or maybe to this one, we have already the Zeta chain pool live on our testnet Kaon, and as already mentioned, they are also already on the docs of Zeta chain. So if you like, you can check them out already. So especially for validators, this might be quite useful to just check those docs out, because usually this works way better than like the native peer-to-peer stuff. And the tool I'm talking about right now is KSync. And this is the first tool of our 3 tools, where basically we target the group validators. Since because we have all the blocks permanently stored on Arweave, it makes sense, of course, if you want to sync a node from Genesis, for example, that you can just like retrieve the blocks from there. Because we experienced it all the time, actually, if you want to sync a node from Genesis, which is quite crucial, to be honest, since only then you can fully trust your node, that you often don't find peers at historical heights. So oftentimes you have to wait quite long. Sometimes the peer-to-peer connection breaks, and then you idle like for even hours until you can sync blocks again. So with this solution, the blocks are always available. You can spin up KSync, which is like a a small CLI tool you can simply install on your machine. And then once it's started, where we will do a live demo after this right now, it will pull down the blocks from KYVE and apply them against your Zeta chain node. This is not only limited to Zeta chain, of course, but also for all the other Cosmos chains we have archived right now. And if you're interested in the Cosmos chains we have archived, you can just check out our web app. We have multiple Cosmos chains there, and we plan to launch even more in the future. And not only can you sync from Genesis, you can also perform state syncs. So in case you don't know what state sync is, it's basically a feature from Cosmos where you can like sync to the live or close to the live height rather quickly, so you don't need to sync like all the blocks from Genesis. If you have like the correct trust height, trust session, all that stuff, and then you can like really quickly join a network. But the downside is oftentimes it's rather complex, and sometimes also you don't find, same as the blocks, you don't find peers which give you like the snapshots. So casing the same game, you can then just spin it up. You can sync actually to any height with this, because we also have historical state sync snapshots archived to an old height or to a new height. If you want to join a network, of course you want to join a combination of those two. So for example, if you want to find out, let's say, what was the balance of the community pool at height X, you can simply perform the sync snapshots right before that height and block sync the remaining ones. So with this, you're like really fast on finding out what the state at a certain height was. So you don't need like a full archival node by demand. If you want to find something out, this is like kind of the trade-off between storage and compute. So if you just need to find out certain states at a certain height, this might be very beneficial. And this one demo I want to show is how I state sync to the live height, because Zeta chain is actually quite big and there are like over 300 chunks. I performed it earlier today because it takes about 1 hour. But it would also take 1 hour if you would do the normal snapshot. It isn't the fault of casing, it's just because of the size, but it's of course no problem. So here I just stated basically that I want to state sync. I specified the Zeta core, the binary, specified Zeta chain as my source, and then of course just specified the chain ID that it's a testnet. And with that, it found the latest snapshots. I accepted it, I want to apply it, and then it downloaded all the chunks and applied them against the app. And after a certain point, after I've scrolled down all the way, you can see that it has successfully applied them. After that, I just continued block syncing. I just specified like a target height I want to sync to, for example, because I know I want to check out the state, and then downloaded the necessary data from KYVE and then applied them against the app. So I can also just rerun it again. So I just switched out the command from state sync to block sync and left everything the same, have a target height here, and then I can simply start it. So it will ask me if I want to sync from that height, and then I can continue there. It will start a binary in the background, and now casing applies all the blocks against the app. And of course, I can just terminate it right now. And of course, after you have state sync with casing, you can start a node normally, or you can like start your validator normally. So this makes it a lot easier to join any network basically. And if you want to find more info on this, you can check out the docs from Zeta chain or the docs from our page. There they have much info on this. And if we go back to the presentation, here are also some important links I will quickly share after the call in the chat. And this was only like the first product, how you can retrieve data from a data lake. And Christopher will now present you a news tool, the DLT, and I will quickly hand over then.
All right, then maybe I will try to share my screen from now on. Maybe Troy, could you stop sharing your screen? I adjusted some permissions, so let's give it another try. Right, sounds good. Or looks good to me. Do you see my screen?
Yes.
All right, perfect. All right, then let's go ahead with the data loading tool. As Troy elaborated earlier, KYVE is building a decentralized data lake of setter chain data. And of course, like the node runners were the first target group we have in mind that we wanted to build a tool, and we built casing, or Troy mainly built casing to actually utilize the data for any kind of node syncing use cases. But of course, with the decentralized data lake in place, we also wanted to build some more tools to utilize this data lake as best as we can. This is why we ended up building our data loading tool, and we call it DLT. And it's a very good and efficient way of loading any data that has been validated through KYVE. For example, setter chain into your data destination. It's pretty easy to use, hopefully. So happy to hear any feedback if someone wants to use it or is planning to use it. It is pretty lightweight, so it's just a Go CLI that actually only downloads the data that has been validated through KYVE, validates it locally, and then loads it into your data destination. It's pretty fast and scalable to your machine. And it currently supports BigQuery and Postgres, but we are planning to add more data destinations to it. If you have, again, any preferences regarding it, you can definitely reach out to us, and we see that we make it happen as soon as possible. And yeah, I've also prepared a quick demo to showcase it. Can you see my screen? Or can you see my terminal?
No, we can only see the slide deck.
Okay, then I will to share the whole screen instead. So now you should see my Goland with the terminal in place. That's basically the DLT repository. I can share it afterwards in the chat. But it comes out with a pretty easy to use CLI. So we can here see or list our.
Sorry to interrupt you. If you can make the terminal a bit bigger so that everyone can see it clearly, great. Sorry.
No worries. Let me quickly see how I can do that.
Maybe it's just Command plus. Sometimes that works.
Yeah, but it works not on my side. Maybe I can put it on another screen there. It's a bit bigger. Right. It should be bigger now with another terminal.
Perfect.
All right. Then let's see. So the KYVE DLT comes out with a bunch of sources and destinations. For example, we can list the sources. Here we can see the setter chain is already defined per default. It has pool ID 10 on our testnet Kaon. And we can also list our destinations, which is in that case our BigQuery destination just for previewing purposes. And we put everything together in our in a connection, which has basically the setter chain connection, which has the setter chain source and the BigQuery destination. And we are right now planning to sync setter chain data into our BigQuery. And the only thing we then need to do is to actually start the loading process. With load, we define the connection. I think it was a setter chain. Setter chain connection. And then we can also define a from bundle ID to not store the whole or load the whole data set, because it's a big, huge for this preview right now, but it shouldn't take that long. We are starting from one of the later bundles. And then it starts the incremental sync to actually download the setter chain data from KYVE to load it into BigQuery, and then we can see how it works. So we see some loading process going on here, and sync took 14 seconds. Of course, it was just a small preview, but the tool itself is pretty efficient. So hopefully you will have a good experience with that. And then we can check our BigQuery to see how the data looks like. And there we can see it has created the setter chain preview. And we can see here that the data has been loaded into our BigQuery. You can see the value, as Troy mentioned earlier, is pretty raw. So here we can see the block and the block results. If we scroll a bit down, we have many transactions going on here on setter chain. But yeah, you have basically the block and the block results. We also provide the schemas of all the data that has been loaded into KYVE using the DLT, and then you can build probably or theoretically everything out of it. So if you want to if you want to build a data warehouse using KYVE data for setter chain, you can therefore use the DLT. And we have also some other cool commands. For example, the sync command, where you can then keep your data destination in sync with the KYVE pool. So for example, if you want to build a dashboard or data warehouse that always has the latest setter chain data, completely validated, completely trustless, you can rely on the data loading tool from KYVE. Exactly for any data usage, I would link the GitHub repository in the chat afterwards. And maybe we can move on to the third tool, the latest tool from KYVE, and that's the Trustless API. And the Trustless API is basically a way of providing the block and the block results of a Tendermint chain, in that case setter chain, completely trustless. And this is allowed by a Merkle proof that is attached to the data item itself when validating it. So I can maybe show it for Injective as an example, because it's right now it's a pretty new feature. So we haven't rolled it out for all chains, but we can showcase it for Injective. But it will work for Zeta chain the same way. And here we have the block, and you should be familiar with it. It's basically we are mocking the block endpoint for Injective in that case. For a height, KYVE has been validated and archived, and the value is pretty familiar, your block endpoint result. And it not only comes with the value itself, it also comes with a proof that can be used to actually verify that this retrieved data can be verified client-side, and that this data has been validated through KYVE. So clients now can ensure that the data that has been retrieved via an API endpoint is completely correct and validated. This also works for the block results. So we can see here, there we have, of course, the TX results, begin block events and end block events, and some other metadata. And here we have also the proof. And this comes also with a Trustless client package. So it's pretty easy to embed that the data has been validated into your running system. And the phrase we are using it or we are promoting it is that you can connect your applications to the validated KYVE data within seconds without relying on any archival node running in the background. And you can make sure that it's actually been validated through KYVE, so it's trustless, which we call it the Trustless API. Exactly. It also is, of course, completely free, because we are aiming to build a completely decentralized data lake that is basically a public good. So nobody has to pay for the whole reading process. It comes also without any query limit. And the rate limiting is also pretty production ready, I would say. Any questions, please leave a message in the chat. I'm happy to answer any questions, especially when it comes to the technical questions, maybe how we ensure that the data is correct. I'm happy to answer any questions about that. But I think we can move on with our presentation. And yeah, these has been the 3 tools we wanted to present to you. You can all use them. The Trust API should be ready in, I would say, 2 to 3 weeks. Then you also can use the Trust API. So we'll have a full historical block and block results endpoint for Zeta chain data. And exactly, we now want to talk a bit about the further benefits or the possible benefits for Zeta chain validators besides all these tools, because as I mentioned, you can already use this tool, especially casing and DLT, but you can also help building, helping for the whole write process of Zeta chain data to KYVE, because right now we have only presented the reading process, but of course there's a writing process that is a bit more Web3 focused, because what happens there is that we have a subset, the pool, as Troy mentioned earlier, we have a pool where the protocol validators are running a Zeta chain node and the KYVE protocol node, a pretty lightweight protocol node. And the more exhaustive part and the more time-consuming part is, of course, maintaining the Zeta chain node. And I don't know how many node runners are in this call right now, but if you are want to get some more services or rewards out of your Zeta chain setup, you can also think of joining the KYVE data pool to help building this decentralized data lake of Zeta chain, which would be great for us, great for Zeta chain as well, because the more validators we get from ecosystems, especially the ecosystems we are validating and archiving, the more decentralized becomes the data lake. So if anybody is interested in running a KYVE protocol validator to help building and validating Zeta chain data, you can check out the docs link I will send in the chat afterwards. So happy to see some of you guys maybe someday on the KYVE protocol to help building the backbone of all these tools we have shown to you. All right. I think that's everything we wanted to present to you. Happy to discuss all questions now. Maybe if you have some other ideas of utilizing KYVE data or any other topics, I'm very happy to chat about it.
Awesome. Thank you so much for the presentation. It was very comprehensive. And yeah, I think we all now have a pretty good understanding of what KYVE offers and how it can be used with Zeta chain. Of course, especially if you're a developer, you can take advantage of all these services. Most of them are actually free, so it's like there's no reason not to use this if you're building an application. I think especially if you're building something that uses the Cosmos side of the blockchain, because from what I can tell, you guys are mostly focusing on Cosmos transactions, so to speak, right? Like you're indexing the chain from the Cosmos blocks. I mean, they're the same blocks, but it's just like some chains, like Zeta chain, are both Cosmos and EVM chains. So I probably asked this question before, but still curious. Like, do you have any plans on supporting EVM indexing to make it easier? Because right now, when I query, I even saw this on screen that it's a bunch of bytes, kind of Tenorman bytes, basically. So you need to decode them first before you can actually make them useful. But if you're mostly interested in EVM side of things, like most developers on Zeta chain are, do you have any plans on this?
Actually, as you mentioned in the beginning of the call, we are early hour Tenorman based. So our first focus was, of course, the whole Tenorman ecosystem, especially like the most important Cosmos chains. We started with Cosmos Hub, Osmosis, Extella, then moved to Arkway, and we are currently like aiming to capture all of the Cosmos ecosystem. But of course, the KYVE protocol is totally data source agnostic, so we can basically validate and archive all kind of Web3 data, all kind of deterministic data streams, which is why we actually are currently validating and archiving EVM data already on our testnet and our devnet. I don't know how familiar maybe you are or any of the devs in the Zeta chain community is. we are actually currently validating the archiving EIP 4844 blobs for certain EVM L2s, for example, Optimism, Arbitrum, Base, like the most important. We are actually doing this right now. So when it comes to DA, KYVE is actually trying to build a good data infrastructure for all the rollups that are utilizing a DA layer, like Celestia, for example, as well, because we are doing the same for them. We are storing the blobs of certain Celestia rollups on our testnet right now. Exactly. And we also have a EVM runtime in place that actually validates and archives blocks, receipts, transactions, and logs for certain EVM chains like Optimism and Polygon. So if you want to check that out, I can of course send some links to the devnet to you guys. So we are already building it out. But yeah, exactly, on the mainnet we are right now focusing on Tendermint, but hopefully you will see some more EVM and maybe some other pools from other ecosystems as well.
Awesome. That's great to hear. I think once EVM is supported, more developers will take advantage of these services. And I think we have some questions in chat. The first one is, what are the implications for data analytics, AI, and machine learning in the context of these solutions?
Yes, so for the first question, I think all the products we have are very big implications, especially like with the difficulty of accessing like historical states of archival nodes, since usually archival nodes only last like 1 week or 2 weeks maybe. All the other data gets spooned because the state grows super fast. And with those tools, you can have like access to all the historical data. So if you ever need to like, I don't know, find certain data or need to make certain queries, you can choose one of those tools and you're good to go basically. So I would just suggest like diving into the docs we wrote, and then it will be very clear very soon on how you can use it, which tools to use, and how we can help you basically. And regarding the AI discussion, actually we have right now on our governance page a proposal to archive training data for AI solutions. So if you want to check it out, you can either go to our forum, KYVE. Unfortunately, I can't paste links into the chat because of, I don't know, permissions or spam protection or stuff like that. Or you can head to our governance or to Minscan, for example, click on proposals. It's called Fair AI Data Validator Proposal. So you can check it out there if you're interested in this topic.
Thank you. You can send links to me and I'll post it later so we don't spend time figuring out Discord permissions. Cool. Next question, how do next-gen data management solutions address the issue of data silos and enable interoperability between different blockchain networks?
Yeah, that's an interesting question. And as we mentioned, we are trying to build a data lake, and a data lake means that a bunch of data is basically dropped to a lake. So we are building a data lake that is, or a lake that has as raw data as possible. So we are like pretty, as I mentioned, like agnostic to the data sources. But of course, we are targeting, or we are addressing this issue with our data tools. To prevent data silos, of course, Tendermint chains are very good when it comes to interoperability, which is why it's pretty nice to build tools like Casing that work from scratch for a lot of Cosmos chains. We have discussions to actually utilize the data lake as well on chain, because with KYVE you can think of a data oracle that can provide historical data for certain chains. So this would definitely be, I think, an interesting tool that could address this issue, or preventing this issue. But yeah, right now we are focusing pretty much on the writing, or we have focused on the writing process. We are right now moving much away to the whole reading process. So this will definitely be a good topic of our next discussions, and we hopefully come up with some cool solutions, because with the data lake in place, I think we have a good base of building tools that help preventing these issues.
Cool. Yeah, thanks for the questions, by the way, Slimzy, Cryptic Web 3. Okay, I just wanted to add to this. I think like when you're building, of course, since KYVE is a Cosmos chain, you are using IBC for blockchain interop. But I think when you're building applications for the interchain, you need access to data, right? And like from that point of view, you provide a very valuable service for those who are building applications that actually provide an interface. And it's a pretty big challenge, because when you're building an interface for a single chain, that's easy. But when you have like 80 chains, try building like a simple portfolio manager, like that's already a challenge, because you need to get all this data from all these chains in real time, because people don't want to see old balances in their portfolio, right? So without something like this, it would be very hard to fetch all the data. So cool.
Yeah, definitely. And this is why we like with the tools, especially with the DLT and the Trust API in place, like that's kind of the base of any kind of data usage, because we are actually providing a tool to use the data to load it into your data destination, and we have an API providing this data in a completely trustless manner. And I think what's interesting there is the more people actually use the data, or the more people getting aware of KYVE, hopefully, because it's a complete public good, everything is open source. So hopefully we will see some more devs onboarding themselves in the KYVE data stack that isn't or in the tech stack that isn't too heavy loaded, I would say. And maybe we see some cool data transformations on the data loading tool to, for example, get either EVM, Bitcoin, or substrate data into your data destination in a pretty cool and transformed way, or either some more cool tools of or some more data runtimes to actually write more data to the KYVE data lake. For example, Bitcoin, or for example, Avail, which is a pretty interesting DA chain in the substrate ecosystem. So hopefully we'll see some traction there. And I see KYVE as a base layer for this whole data infrastructure discussion. And hopefully the more people and the more ecosystems, developer from ecosystems onboard themselves and be aware of KYVE, hopefully the better get the tools to actually create pretty individual solutions for these ecosystems.
Makes sense. Now that I think about it, I think I need to come up with like a short tutorial on how to use your data lake solution. Just kind of a quick tutorial that we can have in the Zeta Chain docs, so that developers who are interested can just kind of go through it. And if this isn't something interesting, go into your docs and read more about it. So yeah, I have to think about it, but it's definitely something we need, because developers are always asking about data providers. Like if you're building anything beyond a simple example app, you immediately start thinking about where do I get the data and how do I use it. Cool. It doesn't seem like we have any more questions in chat. I think I have one more question about security, I guess, from like you mentioned that you don't have aggressive rate limiting, but I'm just curious, like if your service is exposed to the internet, how do you protect from malicious actors that just want to DDoS the service out of existence? Like, are there protection against this, and how is the service remains reliable exposed like this to the World Wide Web?
That's good. And I mean, I think no endpoint is really not rate limit, so which is why I said it's production ready rate limited. So the thing is, or maybe I can get a bit more technical on this topic, because how the Trust API works is, we have a Merkle root that is stored on a bundle on the KYVE chain. This Merkle root includes Merkle leaves for any kind of data item that is in this bundle. For example, we have 10 blocks from height 1 to height 10 in one bundle, and the Merkle root consists of all SHA-256 hash representations of these data items. And this is, of course, stored on decentralized storage provider like Arweave or Filecoin or Lighthouse. And this is like the Web3 stack and the KYVE base layer. And what the Trust API then do is, and everybody can do it because it's completely open source, it's a public good. So everybody can download the data and put it into your S3 or R2 bucket to actually put the data in there and to provide the data from a totally Web2 and pretty production ready environment, and to provide it from this solution. And the thing why it's still trustless is that we have the proof that it's basically a Merkle proof any client can use to actually check if this is the correct Merkle root that has been stored on the KYVE protocol. And the way they verify it locally is they check first, they hash the data they got. For example, they hash a complete block, or they hash any of the block results or any other data item they got from the KYVE Trustless API. And then they create a Merkle proof with the proof that comes within, and then they don't request the R2 bucket or the data destination that works that is running under the hood. It actually needs to query your running KYVE node or any KYVE node that the client is trusting to. So that's the whole web stack, and we outsource basically everything that needs to be scalable, that needs to be production ready for the data usage, and to Web2 giants like Cloudflare or AWS or even Google Cloud. And because in my right now, no Web3 infrastructure can actually compete with those solutions. But the most important part, the trust part, is still completely Web3, is still completely relied on nodes and on the trust to nodes and the decentralized concept of blockchains. So this is still given with the structure. And this is why I said it's basically production ready. Like the rate limit is pretty solid for solutions in Web3. And it's still trustless because you still at the end need to verify it by your own, need to verify it in the best case with your own node running on the KYVE network.
Cool. Yeah, it's great to get a sneak peek at like how it works under the hood. I really appreciate it. It doesn't seem like we have any more questions about KYVE. We have a question about Polygon-based Avalanche and Solana. When Zeta Chain will be connected to those chains. Keep an eye on our Twitter account this week. We have a few announcements that will provide more information on that. By the way, Polygon Amoy is actually already on testnet, so that's a bit of alpha here. And Solana is going to be next. So, yeah. Okay, well, thank you so much for the presentation. It was very informative. Really enjoyed it, and I think everyone else enjoyed it too. So, yeah, Troy Christopher, thanks again. Pleasure meeting you. And thank you so much for joining our DevOffice hours. I think we can wrap this up so that we don't take more of your time. We at Zeta Chain really appreciate you taking the time to make this workshop. We're gonna upload this to YouTube so more people can watch this later and kind of internalize all this knowledge and and hopefully use KYVE in their next project. Thank you so much.
Yeah, thanks for inviting us. It was fun.
Awesome. Well, goodbye, everyone. This was very productive, and I'll see you next month. Goodbye.
All right, guys. Goodbye.
Bye.